we are going to have a look at the product rule. And it's all about finding different permutations or combinations of sets of things. So, for example, into the digits in a password for our first question. So we've got a password, it's got 5 different digits. The first thing to think about is how many different possibilities are around these digits. And it might be quite easy to say, oh, there's 9. Let's have a look. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So altogether, you'll see there are 10 different digits there, with a 0 being the 10th digit. So let's have a think about this password. So we've got to put in 5 different digits. So I'm just going to draw a little possible display to put these digits into with 5 spaces. And we've got to think about all of the possibilities here. So with the first digit, how many possibilities are there? Well, we could put one of 10 different digits in there. So there are 10 different possibilities. For the second digit, we also have 10 possibilities. And for the third, the fourth, and the fifth. So each of the 5 integer digits, there are 10 possibilities for each. So how do we calculate how many there are altogether? Well, all we need to do is multiply these together. And that is going to give us 100,000. And if you think about multiplying by 10, if you multiply 5 10s together, then you're going to get 5 zeros. That seems like it's right. Now, is this our final answer? Well, what if we want the probability? If we want the probability of this, then you're going to think, well, how many combinations are correct? And with a password, there's only going to be one possibility that's correct. So our answer is going to be 1 over 100,000. So you've got a 1 in 100,000 chance of choosing the right password with 5 integer digits from 0 to 9. So that's quite unlikely, isn't it? Next, we'll look at more complicated variations of this. So, for example, a password with 8 integer digits, a much longer password, but we only use the digits from 4 to 8. So the first job is to work out how many digits there are. So there is 1, 2, 3, 4, 5 different possibilities for each digit. And then we think about, right, okay, so we've got 8 integer digits. So for each one, we have 5 possibilities for each of the 8 integer digits. And what is the probability altogether, or the number of combinations altogether? We are going to multiply them all together. And an easier way of writing this, since it's all 5s, is that we have got 8 5s all together. So it's 5 to the power of 8. So the 5 coming from what you can see in green, where we count up the number of digits, and the 8 coming from the number of digits we need altogether. So if we work out 5 to the power of 8 on a calculator, I mean, you can write out all the 5s multiplied if you like, you get the same answer. We are going to have 390,625. So that's how many combinations there are, but your final answer, as usual with a password, there is only going to be one chance of getting the right thing, because there's going to be one of those combinations is going to be the right password. So the answer is 1 out of 390,625. And now a little bit more complicated again, we want an odd password with 7 integer digits from 1 to 8. So as usual, the first job is to work out all the possible digits. And we have 1, 2, 3, 4, 5, 6, 7, 8. So with this password, we want 7 digits. So we're going to have the 8 possibilities, 1, 2, 3, 4, 5, 6, 7 times, and multiply them all together. However, this time I've missed a detail, and the detail is this is an odd password. That means the final digit is going to be odd. So out of all of our possibilities, which ones are odd? Well, 1's odd, 3 is odd, 5's odd, and 7 is odd. So there's only 4 possibilities for odd numbers. So what I need to do is the final digit has to be odd. So there are only 4 choices for that final digit. If you want to express this a little bit more concisely, or we can say we've got our first 6 digits have 8 possibilities, and our final digit has 4 possibilities. If you think about powers, 4 is the same as 4 to the power of 1. So we can see with the indices, we've got the 6 and the 1. They add up to the 7. So if we work that out, we are going to do 8 to the power of 6, and then we're going to multiply that by 4, and that gives us the answer 1,048,576. And when we're thinking about what's the probability of getting 1 out of all of those, we just write it as we said it. we have one of those trying to find, and there are a million possible combinations. So that's the probability of guessing the password correctly on the first try. Now, what we've just done is fairly easy. We're going to move on to some harder ones. We're going to think a bit more carefully about what exactly we did here and what matters and doesn't matter. So what we've done here is this is a permutation. It's a permutation with repetition. So what does this mean? Well, a permutation means that we've got, in this question, over a million different permutations. With a permutation, the order matters. So if you had the right password, but the numbers are in the wrong order, that's a wrong password. So the order of the digits in the password does matter. If it didn't matter, we'll call this a combination. The second thing is a repetition. We have the digits in this question from 1 to 8, but you are allowed to use the digits more than once. You can have a password that's 88888888, and then you'd have a 7 at the end because this one's going to be an odd password. So you can just have the same number repeated. So this is with repetition. And with most passwords, you are allowed to do this. But we're now going to go on to things where we aren't allowed repetition, or it might be we're looking for a combination instead. And to finish off, there is a formula for this. The formula is n to the power of r. N is the number of choices. So, for example, in this question, n was 8 because there are 8 different choices we could have. And r is how many times you're making that choice. So in this one, we have 7 into the digits, so we're making the choice 7 times. So the formula for this would be 8 to the power of 7. However, you'll notice I didn't use that because it's got an extra little bit where it's an odd password. So instead, I use the formula for the first 6 choices, 8 to the power of 6. So basically use the formula twice for each different type of choice. The first 6, which you could take any digit, and then for the last one, which could only be odd. So moving on to the harder questions now. We're going to start off doing this manually, then we'll start to bring in the formulas. So we want the total possible colour combinations. We choose 2 paint tins from 8 total. So let's give our 8 paint tins some names, and we'll keep it nice and simple. So we can have A, B, C, D, E, F, and G. So let's say we choose A first for our first painting colour. What could we have for our second? So we could have A and A again. We could use the same tin twice. We could have A and B and mix them together, which will make a new colour. A and C, A and D, A and E, A and F, and A and G. So they're all the possible different combinations we could choose. Now, what did we choose B first? So we could have B and A, B and B, B and C, B and D, B and E, B and F, and B and G. So there are all the possible combinations if we choose B first. So now I'm just going to quickly populate the list because we can kind of see the pattern. It is called being systematic. I've done a little system here, and that means I can now quickly write out all the colour combinations. Now, one thing you might notice here is that we have some repeats. So, for example, in our first choice, we have A and B. Now, we also have that here with B and A. Now, you think about how combining colours works, the order doesn't matter. If you mix together red paint and yellow paint, you get orange. Do the other way around and mix yellow paint to red paint, you're still going to get the same shade of orange. So what we can do here is we can just cross that one out. We don't need it. We've already got it. And I'm just going to look through my list and try and find all the repeats. So for example, A and C, so C and A is a repeat. A and D, so D and A is a repeat. So it looks like all of this column is going to be our repeats for the first row. Now let's look at the second row. So we've got B and B. There's no other B and Bs. But then we've got B and C, and that's the same as C and B. The way this kind of goes is, if you look at the kind of the central column where we've got A and A, and we're going diagonal, B and B, C and C, D and D, and so on, you can see all the repeats are underneath that line that I've just highlighted in pink. So now we can count up how many and get our final answer. So in the top column, we've got 8, then we've got 7 in the next, 6 in the next, then 5, 4, 3, 2, and 1. So we can add all of those up. 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Altogether, there are 36 combinations. So we've worked it out manually. We know for sure that 36 is the correct answer. Let's look at faster ways of doing this now. So I'm just going to rub this out to get some more space. So what we need to think about here is it Permutations are combinations. Well, the question says combinations, and with a combination, it means that the order doesn't matter. Whereas with permutations, like a password, the order doesn't matter. We mix some paint colours together. It doesn't matter which way around you do it, you'll get the same shade. So this is combinations. The next thing is thinking about if repetition is important. And for combining paint colours, it is important because you want to combine the same to the paint with itself. For example, if you wanted red, then you combine together two reds and you have a larger quantity of red. But we didn't allow that. And you could only mix red with something else. If you need red paint, but you can't have red twice, so it's like red and yellow or red and orange, you're not going to get that shade of red. So you do want repetition. This is combinations with repetition. What's the formula? Well, the formula is quite a complicated one. It's plus n minus 1, all in brackets with an exclamation mark. We'll talk about what that means in a moment. And that's been divided by with an exclamation mark and n minus 1, close the brackets, and another exclamation mark. So what does this mean? Well, the and the n mean the same thing as we were talking about before. So is the number of times you're choosing. So for this one, we are choosing twice. Let's highlight it. And n is the number of choices. And for this, we have 8 possible choices. So all we need to do is substitute those into our formula. So every time we see an I'm going to write in a 2. Every time we see an n, I'm going to write an 8. And then don't forget the exclamation marks. And so we're going to need to try and work this out. Now, to make it a bit simpler, let's do the bits that we can do first. Let's do the top bracket. 2 plus 8 is 10, minus 1 is 9. So we have 9 and the exclamation mark on the top row. And on the bottom row, we have 2 and the exclamation mark. And that's being multiplied by 8 take away 1 is 7. So that's 7 and the exclamation mark. So now, to work this out, what 9 with the exclamation mark means is it means factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's been divided by, we've got 2 factorial, which means 2 times 1. And then that's been multiplied by 7 factorial, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1. So factorial is just a way of saying take this number and multiply it by every whole number below it all the way down to 1. Now, there's 2 ways to go from here. The first way is there's actually a factorial button on your calculator. On my calculator, it looks like this, an X with an exclamation mark. And it's actually one of the shift functions. I've got to press shift, and then I've got to press the button that's underneath that. You may also see it on your calculator as just an exclamation mark on its own. It might have its own button, or again, it might need to press shift first. So you can use your calculator to do it. Another way to do it is by cancelling out. So I can see that all of these I've got a 7 times 6, 5, 4, 3, 2, 1. So if you divide the same thing by itself, you're going to get 1. And what I'm left by is on the top row, I've got 9 times 8, which is 72. On the bottom row, I've got 2 times 1, which is 2. So if I do 72 divided by 2, I get 36. And also, if you did this on your calculator, you should get 36. And you'll see right at the top, we wrote down 36 combinations. That's what we calculated without using the formula when we just wrote out all of the possible calculations. Now, honestly, you can see this is quite a complicated formula, and usually on the exam, there won't actually be that many combinations. There might even be less than 36 combinations. So drawing it out manually might be actually a decent strategy, but we're going to move on now and look at some where we actually can't work them out manually because there'll be so many combinations. So with the next question, we have ice cream combinations when you choose 4 scoops from 12 flavours. So this is going to be combinations because the order doesn't matter. Eating vanilla then chocolate will be the same as eating chocolate then vanilla. You can eat it in the order you want. And then repetition is okay here because it might be that you really, really like a flavour and you just want double the amount of chocolate ice cream. So you have 2 chocolate and 2 vanilla, or maybe even 4 scoops of chocolate. That is an option you're allowed. So it's combinations with repetition. How many times are we choosing? We are choosing 4 times. R is going to be equal to 4. And then how many choices are there? There are 12 different ice cream flavors to choose from. So n, the number of choices, is going to be 12. All we need to do is copy out the formula and swap in the numbers as we need. So we've got plus n, take away 1, and all that is a factorial all over. And then we have factorial multiplied by n, take away 1 factorial. So work out the brackets. 4 plus 12 is 16, take away 1 is 15 factorial. And on the bottom, we have 4 factorial multiplied by, and it's 12 take away 1, so that's 11 factorial. So, I mean, you could potentially write it out like we did before, and you can cancel out. You can potentially do it without a calculator if the numbers aren't too big, but it's a lot easier with a calculator. So I'm going to type in 15 factorial, and I'll press divide. And then what you might want to do here, just put a bracket around the 4 and the 11. So your calculator knows that both of those are being divided by the 15. So I'm pressing 4, the factorial button, 11, and the factorial button, and then I'm closing the brackets. One extra little thing, I just got a syntax error on my calculator, so we do want to put a multiplication sign in between as well. So I'm going to type it in all again. 15 factorial, divide, open a bracket, 4 factorial multiplied by 11 factorial, and now I've got an answer, and it's 1,365 different combinations of ice cream flavors. Again, we're not including different orders, so we're not including chocolate, vanilla, 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 or vanilla, 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 chocolate, or any other combination of 3 vanilla and 1 chocolate, because they're all the same thing. But we are including choosing the same thing multiple times. So vanilla, 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 or vanilla, 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 chocolate, where we just choose the same flavor over and over again. That is allowed. So now looking at a different context for this, we looked at ice cream flavors, we looked at paint colors, now we're looking at spices. And again, with spices, it doesn't matter which order you put the spices in, if you put them all in, together. Maybe if you cook your food and you put the spice in half an hour later, it might have an effect. But what we're talking about here is that we're making a spice mix. I'm just putting all the spices one after another into a bowl. So the order doesn't matter. So this is combinations. And repetition, do we want to put larger quantities of some spice than others? Well, yes, we do. So we do want to be able to choose the same spice multiple times. So in combinations with repetition, how many times are we choosing? We're choosing 8 spices, so we're making 8 choices. How many different choices are there? There are 14 choices. So R is going to be 8. We are making choices 8 times. And N is going to be 14. There are 14 different choices. So again, let's copy down the formula. So we have R plus N, take away 1. All of that is a factorial. It's being divided by R factorial and N minus 1 factorial. Let's do the brackets and simplify it. So we've got 8 plus 14 is 22. Take away 1 is 21. So that'll be 21 factorial for the numerator. And for the denominator, we've got 8 factorial, and it's going to be multiplied by the bracket, which is 14 take away 1. That's 13 factorial. And again, to make it friendly for your calculator, we can just put brackets around the bottom so it knows that both terms are part of the division. If we didn't do the brackets, it might do the 21 divided by 8, get an answer, and then multiply by the 18, which you don't necessarily want to do. So type that into my calculator, 21 factorial divided by, open brackets, 8 factorial, multiplied by 13 factorial, and that's giving me 203,490. That's how many possible flavor combinations you can get when you choose 8 spices from 14 different spices total. So that's a lot of different variation in flavor. So now let's look at different context. We have finding the top 2 in a league with 18 teams. So what I mean by this is, you're kind of betting on what the top 2 teams are going to be in a league. And I'm going to imagine here you don't know anything about football, so you can't really think like, oh, that team's better, they've got a higher chance of being at the top. What we're thinking here is that each team has got an equal chance of being in the top 2 because we don't know anything about it. So how we work this out? Well, firstly, we're going to think, is it combinations or is it permutations? So does the order matter? And with the top 2, the order does matter. You're going to get number 1 and number 2 in that order. If you had done the wrong way around, then you've not worked at the top 2 correctly. So this is going to be permutations. Then we have to think about repetition. Are we allowed to have repetition? Well, can you have the same team twice being place 1 and place 2 in a league? No, you can't. So we want no repetition. Now, there is a formula for this, and the formula is a little bit easier for this one. The formula is n factorial over n minus r factorial. And just a little reminder, what is n and what is r? So n is a number of choices. And how many choices do we have? Well, we've got 18 teams. So we have 18 different choices for our first and second place teams. And r is the number of times we're choosing twice. We're choosing the top two. So let's substitute into the formula. So we want 18 factorial divided by 18 take away 2 factorial, which would be 18 factorial over 16 factorial. So we can type that into a calculator, and that is giving me 306. So what is the chance of me choosing the top two the teams in a league with 18 teams? It's going to be a 1 in 306 chance. Now, one extra thing to look at here is there is actually a calculator button for this, and the calculator expression is NPR. And you can see the connection here because it's permutations, so there's a P, and we've got the N and the R, which we're using in the formula. So on your calculator, what you would do is you would press N, which is 18. You would press the NPR button. Now, this might be written above the NCR button that we might talk about. So you might need to press Shift first, and R is 2. And if you type that into your calculator, I'm getting 306. So it's giving us the correct answer. So that'll make it a lot faster to work this out. So moving on to the next question, we want to choose the top 3 teams in a league with 24 teams. At the start of the season, we don't know what's going to happen yet. We don't know about the sport. Maybe it's football. So we're just going to choose 3 random teams. So we've got 24 possible choices. So n is 24. And how many times are we choosing? We are choosing 3 times for place 1, 2, and 3. So is 3. It's permutations with no repetition. We don't want to choose the same team more than once. That's impossible. And it's permutations because the order does matter. Now, remember the last question, we've got a little shortcut here, so we can press the NPR button. Do I press N or R first? Well, look at what it says. We've got the big P for permutations, and the N is first. So we're going to type in 24 first. Then we're going to press the calculator button for NPR, and then R is going to be last because the R is after the P. So you type in 24P3, and you get an answer, and I'm getting 12,144. So what's the probability of choosing the top 3 teams in our league at random? It's a 1 in 12,144 chance. Now, for the last question, we have a lottery, and we're choosing 6 numbers out of 25. So we've got to think, is this permutations or is it combinations? Well, does the order matter? And with a lottery, it doesn't matter what order your 6 numbers come out in, you're going to win no matter what order they're in. So this is going to be combinations. Then we have to think, is repetition okay? So in a lottery, are you going to have the same number more than once? And you don't. So it's combinations with no repetition. Now, for this, there's a formula similar to the permutation formula with no repetition. And it is, you have n factorial over r factorial and n minus r factorial. So it's kind of similar to the previous formulas. We've got an extra r in the denominator, but we're going to work it out the same way. So we're going to work out what n and r are. So for n, we want the number of possible choices, and there are 25 choices. N is going to be 25. And for r, we are going to want how many choices we're making, and we're making 6 choices. So let's substitute. So it's going to be 25 factorial divided by 6 factorial, and that's multiplied by n minus r factorial. So n minus r is going to give us 25 take away 6, which is 19. It's 19 factorial. So we can type this into our calculator. So just remember, make sure the denominator's got a bracket around it. If you've got multiple terms on the top or bottom of a fraction, contain them in a bracket so your calculator doesn't get confused. And then make sure we're writing in the multiplication sign. So 25 factorial divided by, open the brackets, 6 factorial times 19 factorial. And that's giving me 177,100. So what is the chance of choosing these lottery numbers at random? It's 1 out of 177,100. Now, like the last one, there's actually a calculator shortcut for this as well. You might have seen the button for it when you're typing in NPR, and for this, the button is NCR, C for combinations. So type in N first, the 25, press the calculator button, NCR, and then type in R last. Remember the order of N and R, you can see it because the N and R are next to the C. And if you get it the wrong way around, you are going to get a calculator error anyway. So if you type in 25, C6, that will give you, again, the 1000 or 177,100 number. So it gives you the same number.
Ouch! This is why in some videos I have explained scratches.